Introducing Fishing for Change, Engineering a Fish Passage by Team Flying Fish.
My name is Amy Sauceda.
My name is Ben Lyon.
My name is Cody Miller.
And my name is Matthew Donaldson.
All right, and here's a quick animation behind the motivation for FEDD.
All right, so now that you've seen the motivation in general behind our design, this is the engineering design cycle and how we applied it to our project. First is to ask the driving question behind our project and behind how we're going to make our product. We then imagine, research, and brainstorm. We plan out how we're going to make the design. We created it using computer-aided design and 3D printing and improved it and made changes as needed. First up in the design process is to ask, and the driving question behind our project was how to design a fish passage that allows a fish to more easily navigate upstream past an obstacle. The requirements were to reduce the downstream flow velocity, increase the water depth within certain parameters, and fit within the dimensions specified. The next stage in the design cycle is to imagine. We first researched, we looked at established fish passage designs from a variety of settings. These include the dental fishway, the cone fishway, and the one we decided to go on, which is the vertical slot shown here in the diagram. This goes into a little bit more of a detail about the vertical slot design. There's some heat maps showing how where the water is most concentrated as it flows through the vertical slots. The vertical slot creates some vortices for the water and in general slows down the velocity.
Using what we had talked about in the imagine design stage, we then created multiple different 3D models using a CAD software called SolidWorks. We would then use those models in flow simulations to represent what the water would do in situations in this situation. After creating the 3D models on the computer, we then 3D printed them so we could test them in the flume. Using both the practical data from the tests in the flume and the SolidWorks flow simulations, we were able to refine our design and switch from version 1 to version 2. To better communicate between the team members and between us and the gurus, we created SolidWorks drawings that shows all of the dimensions and details that we needed to accurately represent.
The challenges we received were from version 1. It had too much turbulence, which was caused by the eddies, which is shown by the red arrows. The main purpose of those was to have the resting period for a fish. Like according to Quaranta, they're necessary because it's like for fish to collect their thoughts, kind of. But this caused the water levels to be too high and a little too low, but it was mainly the velocity in the downstream that was an issue. Another thing we saw, we added walls which were unnecessary and it caused the model to look a little too bulky. In order to overcome this, we fixed the turbulence by flipping the curves of the wall, as you can see in the top right corner. instead of going against the water flow, it's going with the water flow. We also included holes in the walls so that in case there is turbulence, it could just easily flow through. This significantly changed the water levels, especially the upstream. It definitely did decrease. The downstream didn't change much, but the velocity did. We removed the walls, which allowed more space for water to flow a lot more easily.
Now, built in with SolidWorks was SolidWorks flow simulation, in which we were able to put our SolidWorks models inside of a flow simulation and determine the flow velocities of the water going through it. Now, as you can see in the flow simulation GIFs on the presentation, up to the top left, you'll see a color meter indicating the velocity of the water. And if you look at the pictures, you can see the dots, each representing different flow velocities. Now, when looking at version 1, you can see a ton of dark blue, which is not good. This is something we struggled with, especially on our first vertical slot design, and something we eventually overcame in version 2. And when you compare the two, you can see much higher flow velocity present in version 1, but version 2 has much smoother flow velocities. You can see a lot of green and orange in version 2, which is exactly what we were looking for. Now, when looking at the real life examples at the Flume at Weaver Labs, you can see the simulations accurately reflected what happened in the actual flume. In version 1, you can see tons of turbulence and extremely high flow velocity towards the end of the model and a little bit towards the front. While in version 2, you can see an overall smooth gradient of water all the way across the model.
All right, finally, advice for the incoming freshmen. The main things I would say, we would say is be adaptable, because out of the 3 choices you would get, the probability of you like having any of those 3 is very low. So just be expecting that. Another thing, a timetable, like have a timeline of each deadline and follow that deadline strictly. And if your project requires or you think needs testing, do the testing, because from testing, we went from version 1 to version 2, which you saw had a significant change.
Thanks for listening.